Yeah.
Do they ask discrimination for this term?
Oh no. Just to use it. Yeah. Okay. Right, we'll start the next lesson now. So, although it seems like we're moving on to a new chapter, the next lesson is still part of the chapter sequencing series. But we're going to have a look at more in detail what a sequence is. Oh, come on. Okay, do we know this word? Does anyone know this word, sequence? Somebody knows it. Do you want to try and explain it? Go on. Who said that? You said you knew it?
Yeah.
Yeah, go on, try and explain it then.
There's like two different sequences.
Ah, yes, there are two different types, yeah. But a more general English definition, not in maths class, English class. What would the word sequence mean?
A group of something that increase or decrease.
So firstly you think it's a group of things, yeah, and you're thinking it could increase or decrease.
A list of numbers.
List of numbers, yeah, and?
A list of numbers in
Calculation.
orders.
A list of numbers in some order, but maybe it increases, decreases, increases, decreases. So what do we mean by order?
That are in order.
Order of what?
A logical.
That's what I'm looking for, yeah. So it's a list of numbers, but there's some rule for making the list. As you said, a logical order. Okay? So for example, if I had a sequence, something like 2, 4, 8, 16, I think everybody can see what the next number is.
32.
The next number would be 32, because the rule is to multiply by 2. What about something like this one? What would be next here? 19. Okay, let's make it a little bit trickier. What's next?
24.
24, yeah. And what's the rule? Add 1, add 2, add 3, add 4, add 5, and add 6. So this is what I mean when I say sequence. As you said, it's a list with a logical order, a rule that connects each term. So actually a little bit of vocabulary. This is called the first term, and that is the second term, and so on. And the general name for a particular term is called the nth term, meaning somewhere in the list. Okay. So now onto the formula part. So I hope everybody knows at least what a sequence is, okay? But we said there's a rule to the sequence. So there are two ways to write the rule. The first one is directly as a formula. For example, if I write un equals 1 plus 6n, this u here stands for the nth term. So for example, u1 is the first term, u2 is the second term, u3 is the third term, and so on. And what you do to make this sequence is you put in the value for n as 1 if you want the first term, 2 if you want the second term, and so on. So here will be 1 plus 6 times 1, which is 7. 1 plus 6 times 2, which is 13. 1 plus 6 times 3, which is 19. So the advantage here is you could jump to any term that you want. So for example, if I said the 100th term, what would that be? What would it be? It'd be 601, yeah. So this is what you might call a sort of direct formula. In this first lesson on sequence and series, the formula will be given to you. But in the next lessons, you will have to find the formula yourself. Okay? So this is what you might call a direct formula. Now what comes next is maybe new for some people. Recursive sequence. Okay, can we go down? Yeah. You have this, well there's not too much there anyways. So for example, has anybody ever seen a sequence like something like this? Has anybody seen the formula written like this before? As an example, for example. So this is what you call a recursive sequence. So let me explain how it works. You must be given the first term, that's U1. So in this example I said U1 is 1. And then what you do, to calculate U2, that would be 6 plus 7 over U1. Here, if you want U2, it's 6 plus 7 over U1. Notice that this term is the one before this one. So for example, if I have 1, 2, 3, and n, what's the next one? It'd be n plus 1. So this piece is the one that's before this piece. So if you want U2, you would have to calculate 6 plus 7 over U1. But you know what U1 is? What is it? It's 1. So it'd be 6 plus 7 over 1, which would be 13. Now, if you want U3, that would be 6 plus 7 over U2, which would be 6 plus 7 over 13, which would be 85 over 13.
This is the value of the first three terms or just the third term?
What do you mean? Say that again.
You combine first term, second term, third term, or just the third term? Value.
The first term is used to make the second term. The second term is used to make the third term. And the third term is used to make the fourth term. It's a bit like with Pascal's triangle, where the two numbers previously are used to make the next number. And you can't skip any lines. You have to do each one at a time. And what would be the fourth one? That would be 6 plus 7 over the third term, which would be 6 plus 7 over what? 85 over 13. Which would equal 601 over 85. Now I would like everybody, just to make sure we're getting an idea here, I want everybody to calculate the fifth term for me on your calculator, please. And don't worry, we'll do more examples of this because I think this is new for everybody, or most people.
Excuse me, can you go up a little?
Yes, here?
No, just
More?
yeah, more.
How much more? Here?
A little bit?
Oh my goodness. Here?
Yeah.
Right.
So what's the difference between you have like here?
Yeah, what's the big difference between the two? So if I said un equals 1 plus 6n, or if I said un plus 1 equals whatever, 1 plus 6 over un, what's the big difference between these two formulas, the direct and the recursive? What's the big deal between them? Well, can you tell me what the 100th term is in the first formula? Yeah, it's 601. Can you tell me what is the 100th term in the second one?
Yeah.
Eventually, yes, after a while, yes. You can only tell me what the 100th term is if you know what the 99th term is. You can only know the 99th if you know the 98th, and so on. Down until you get back to the first term, which I should tell you. Yeah. So the big difference between the two is with the direct formula you can jump to any part in the sequence. But with the recursive, you're only allowed to jump one space at a time. It's a bit like the difference between using the C or using Pascal's triangle. With Pascal, you can't jump. You have to go one row at a time. But with the C function, you can jump to any row. Yeah? Question?
With this, we can need to add like only one sequence or to like every sequence.
Say that again. Which the recursive?
Is that general formula or a formula only for one sequence? Or
So yeah, some sequences can only be written as a recursive. Some sequences can be written as both. You know, so some sequences, yes, you can only have a recursive, but some of them you can have both. And in fact, this is what your coursework is about. So your coursework will be looking at these two types of sequences. Okay. And in your coursework, you will look at how to go from a recursive formula, which is quite inconvenient, to a direct formula, which is more convenient. Yeah, that's what your project will be about. Going from the recursive formula to the direct formula is not an easy thing to do. But if you can make the change, it's very useful, because then you can jump to any term. Yeah? You get the idea?
Because like the first formula, the sequence is increasing,
Yeah.
and then
Oh yeah, and we'll talk about their behavior later in a moment, okay? So yeah, sometimes recursive sequences increase, sometimes they decrease. Yeah, we'll get to that in a little bit, okay? Alright, what's the next term here? What's the fifth term? What was it? 6 plus 7 over 601 over 85, which is 4, 2, 601. Yeah. Okay. Let's have a look at another one. Can I scroll down? Question? No? So look, the way I also think about this example, if there's a question, don't be shy. No? If I have un plus 1 equals 6 plus 7 over un, you can think about it like this in words. The next term is equal to 6 plus 7 over the last term. So for example, if I start at 5, the next term will be 6 plus 7 over 5. Wherever that is, 6 plus 7 over 5. That is 37 over 5. So then the next term will be 6 plus 7 over the last term. It's just another way to think about it. If you want to think about it in words, it's like this. So the thing about recursive, the word recursive in English means like to go back into itself. So once you have the first term and you put it in to get the second term, it then goes back in to give you out the third term. So it has to keep feeding back in on itself. There's slightly different ways to write the formula. If I wrote this, it's exactly the same as the formula I showed you a minute ago, because if you think about your sequence, it goes 1, 2, 3, dot, 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 n, first, second, third, nth. What is the term after n? It's the n plus 1 term. But what is the one before n? N minus 1. So this piece here is still the piece before this. And if you think about it, you could even write it like this if you really wanted to. un plus 2 equals 6 plus 7 over, what would I need to write here, do you think? N plus 1, because this is still the piece before this. N plus 1 is before n plus 2. The only reason I'm showing you this is because in the exam, they could write it like this or the other way. It's still the same thing. Now let me just give you a sequence. Let's say something like un is 1 plus a half un minus 1. And I'll tell you to start at 2. So I want you to give me the first 6 terms here. First 6. So I already gave you the first one. So I need you to get me the second, the third, the fourth, the fifth, and the sixth. Finished? No? What's wrong? So what is the next term? 1 plus a half times 2. 1 plus 1 is 2. And then 2, 2, 2, 2. See, you thought you had a lot of work to do. So one feature you notice about a recursive sequence, basically once 2 of the terms are the same, then it's clear that the rest must be the same, because you're doing the same calculation again. The 2 goes back in. Yeah. Now sometimes you get sequences that go like this. You could have like 2, 1, 2, 1, 2, 1, or you know, something like 2, 1, 1, 2, 1, 1. They keep repeating themselves. So if we have something like this where it repeats, we call it periodic.
How is it repeating? Because
Well, this one is repeating, the 2 is repeating. I'm just giving you another example. Maybe you have a sequence that goes 2, 1, 2, 1. Here, I'll give you another one. Let me show you. So let's say you have this sequence, un equals minus un minus 1. And I start with 2. What's the next term? What's next? Who can tell me? Minus 2. And next one is 2. Now, once I've gotten back to 2, I know I'm back at this calculation because I'm doing the same thing again. So I already know what's next. What's next? Minus 2. And then because I'm back at minus 2, I know what must become next. 2. So now I know forever it will be stuck between 2 and minus 2. So again, this one we call periodic. Okay, so let me just open up Excel here for a moment. So let's say I have a sequence like, let me see. Let's say I have something like, okay, something like this. Sorry, let me write it down for you. So I have my sequence is minus 7 plus 4 over un minus 1. and I tell you to start at 8. Okay. Right. So can you just read this formula back to me? So what was the formula? -7 plus over the previous term. Yeah. So the next term after 8, if you can see, will be -6.5. Can you see that? And the next term after that will be -7.6. So I can use Excel to jump all the way down to 100. So the 100 term is -7.53. Now you notice very quickly what's happening to this sequence. Well, it's staying at around about -7.53, and then you can see, if I show you more decimal places maybe, yeah, around about here at the 12th and the 13th term, it's still changing, but the change is so small you can't calculate it. So this sequence very, very quickly stops changing. And there's a name for this, when the sequence seems to stop changing. Does anyone know it? No, so we call this sequence convergent. So convergent means it stops changing and it reaches a level. Yeah?
Can we see its graph?
Yes, you want to see what this looks like. Now I think, yeah, I'll highlight the first 20 terms. Insert chart, and we'll do the bar column chart or the bar chart as usual. So this graph is a little bit strange. It starts off as positive, then quickly flips to negative, and you can see that it very slowly changes, but it stays at around about this value. So this is -7.6, -7.5, -7.5, and then it stays there. So when this happens, we call it convergent. So this sequence is convergent. And it seems to be converging to about -7.5. But anyways, this is your vocabulary. We call this convergent. And the opposite of convergent, anybody? Divergent. Yeah. What? Was somebody tempted to say unconvergent? No. Divergent is the opposite. So let's have a look at an example of something that's divergent now.
Excuse me?
Yeah.
In the graph, because the number of terms, we can have one point something. It's like jumping 1, 2, 3. So
Yeah.
in the graph, can we have like a line for the graph or not?
Oh, will the graph look like? Oh, you don't like my
Because
bars?
we don't have values of the term within, like the term 1,
Yeah.
and you want the term 2.
Yeah.
You can choose something between.
Yes. Go on. So what are you asking me?
So to make it like easy, simple with the graph, can we draw a line?
No. Usually for sequence graphs, we draw them as bars. Now, my graph was a bar chart. If you want to make the bars touching, have the bars touching, that's okay. But we don't really use lines for these types of graphs. We usually use bars. It's just a normal practice.
Because there is no values between 1 and 2 or 2 and 3.
Yeah, I guess so. So this is why you don't like the bars. Use bars. Only because that's what's normally done. But we can talk more about this when you're doing your maths project, because this is part of the coursework. Yeah. Alright. Let's have a look at a convergent sequence. divergent sequence. That would be even better. So let's say we have a look at a sequence like this. un plus 1 equals 3un, and I tell you to start at 2. So what will be the next term? 6. And after that? 18. And you can see very quickly it becomes extremely big. See that? So this sequence is called divergent. Now in the exam, the only way you can really know if it's convergent, divergent, or periodic is by looking at the first 6 terms. But calculating these first 6 terms can take some time. 1, 2, 3, 4, 5, 6. So I'll show you a quick way you can do it on the calculator. You'll get me in a moment. There we go. Yes. You like my video? No. Oh, amazing. Right, calculator. So if you take this out, I want to show you clearly what to type on the calculator so you can do the same thing. You can try to do the same thing on that, but if you have this one or similar, it'll work best. A Casio calculator, yes. Yeah. Alright. So let's use this sequence as an example. This will really work on every calculator, I think, except actually for, let me have a quick look. Should be okay. Oh, I'd be surprised if it works on this. Can I see? I think this should work on it. Yeah. The key thing you need is A and S button, answer key. Maybe it'll work for you. Maybe. Alright. Oh, great. Hang on. A very cheap computer. Okay. Right, so we can see this. Hold on. What? Yeah, yes. So just type in 8 first. And then hit equals. Okay, and then you can see the AC button. Press that. So yes, it should be clear now. Alright. Then type in the formula, which is -7 plus 4 over. So it'll be -7 plus 4 over, and then press the A and S key. So let me show you what you should have. Wait. Can you see? Yes. This is what you need to have. Got it? -7 plus 4 over A and S. Now this is where the problem might be on your calculator. Have you typed that? Now press equals and everybody should have minus 13 over 2, which I think is the same. Yes. You got it. Minus 13 over 2. Now if you press equals again, this is the third term, and then you can keep hitting equals. Now keep pressing it until yes. Yeah, until, remember, this was the value that settled on the earlier. Yeah. It should stop changing though after 6 or 7. Yeah. You get that? Yes. Well, hold on, let me have a look. Right, what did I tell you to start with?
8.
8. Right, and then where's your AC button? Delete, I guess.
No, that's remove.
Right, where? Yes, great, okay. A and S is here. So, minus 7 plus 4 divided by
What's the
answer.
seconds here? Is it minus 13 over?
Right, there you go. Did it work on this? Amazing, amazing. Right. So you can see that this is useful for the exam. It's a quick way to generate the sequence, and you can see if it's convergent, divergent, or periodic. All right. Another example. Don't need this anymore. Okay, let me show you another sequence up here on Excel. Now guys, come on, look up. Let me think.
How do you know it's recursive? The first one was 8.
Yeah, the 8.
Second one, the second one, minus 16.
Over 2.
Okay. Let me just go to. Right, look up, please. Look up. Look up. Hey. So, let me just squeeze here a bit to the right. Okay, so here's a sequence. It's not important right now how I made it, but you can see the sequence here. So it starts with 1, and then the next thing is 1.5, 1.83, 2.08, and so on. So if you were looking at this sequence, would you say it is convergent, divergent, or periodic? Well, firstly, periodic, definitely not periodic. So the question is it convergent or divergent? So let's keep going down and see. So this one here looks like it's divergent, yeah? Okay, so let's try another one here. Well, sorry, same sequence, but now, how far will I go? Let's go up to the 1000th term. Well, we can go a little past the 1000. Right, what do you think now? Is your answer still the same? So, convergent, divergent. So here it is after 1000 terms.
It's the same or different? Divergent.
You still think divergent? Yeah. So what I'm saying is, sometimes we can't always tell by looking at the first 6 terms. Here you have to go much further than 6. Sometimes things look divergent, sometimes things look convergent. Like if I changed it a little bit, now what I'm doing you don't need to worry about here. So let's go to 1000 again in this new sequence I'm making up. Whoop. Right, so let's have a look at this sequence. So this is my second sequence. So you're all right, the first sequence was divergent. So if we look at this one, what do we think here? Divergent, yeah. And if we go all the way down?
Divergent.
We think divergent, yeah? Now let me just check one thing here. Hey, come on, just look up. Right. Right, this one here, what do you think now? Divergent for this one? Because what's happening? It's increasing, yeah? This one is convergent. And the point I'm making is just because it's increasing doesn't mean it will increase to infinity. And let me give you an example that's maybe a little bit easier to see, okay? So, suppose I had...
Is there a tool to...
Yeah, it looks like it's getting bigger, and it is getting bigger each time, but it won't increase forever. It does actually settle down. Let me give you another one here. Okay. That no good. I did something wrong. Right. Right. Sorry. Have a look at this one. Okay. So have a look at this sequence. Look up 1.5, 1.75, 1.875, 1.9375. It's increasing. So this might make you think it's divergent. So let's jump forward a little bit. Okay, right, so let's jump all the way down to the 20th term. Now, do we still think it's divergent? No, now it's convergent. And in fact, you could probably see what it's convergent to. It's convergent to 2. So let's jump down to... Two. Now, it's not quite at 2. It's just so near 2, the program rounds it to 2. Okay? So, the real point I'm trying to make you see here is, just because the sequence is increasing, that doesn't mean it's divergent. Okay?
Increasing the decimal list.
For us, we don't need to know on this course what exactly you need for it to be convergent or divergent. It's just enough to try and make a guess from the first 6 terms. But in the exam, they'll always give you a sequence where it's very obvious what's happening. So for example, in the exam, you'll have a sequence that will go 10, 20, 1,000, 1,000,000, 1,000,000,000. What do you think this sequence is doing? Divergent. Yeah. And then you'll have one sequence that will go 1.9, 1.99, 1.999. So again, this is clearly convergent. And then there'll be one sequence that will go like 211 or 213, 213, 213. So that sequence is definitely periodic. Okay? So in the exam they'll make it clear. But I'm just trying to let you know that you can't just tell from seeing if it's increasing or decreasing. Okay? Let's have a look. Right. Number 1. You know what? ABC in each question. And don't forget 5, 6, and 7. And 5, 6, and 7. And number 7 is rather important for your project, because in number 7, notice the formula in number 7, it depends on the last 2 terms, fn minus 1 and fn minus 2. You see that? So the formula depends on the last two. Alright, we'll finish there, so.
It's not due tomorrow, right? It's not due tomorrow.
This one, no. You can have, we have class on Wednesday, don't we?
Yeah.
Yeah?
Tomorrow or not tomorrow?
Yeah. But I'm asking, we also have class on Wednesday, yeah? So I'll check this on Wednesday.